Number 6, consider the curve given by the equation y cubed minus xy equals 2. It can be shown that dy dx is equal to y over 3y squared minus x. Part A, write an equation for the line tangent to the curve at the point negative 1, 1. Okay, asking us to write an equation of the line, so we know our answer has to be y equals mx plus b. All right, so let's write down what we know. The x value, they told us, is negative 1. The y value, they told us, is 1. And the m is going to be the dy dx, because dy dx is a slope, so we just need to plug in negative 1 and 1 in there. And when I do that, I'll get 1 over 3 times 1 squared minus negative 1. And when I do that, I will get 1/4 for my slope. So we now have 1 equals 1/4 times my x value plus b. That will give me 1 equals negative 1/4 plus b, so b will equal 5/4. So the equation of my tangent line will be y equals 1/4 x plus 5/4. We could have also written it as y minus our y value equals m times x minus the x value, which would be plus 1. So both of those would be correct ways of writing that problem. And we get 1 point for finding the slope. So if you found 1/4, give yourself a point. And then if you were able to find the equation of the line, give yourself another point. Okay, part B, find the coordinates of all points on the curve at which the line tangent to the curve at that point is vertical. So if we want a vertical tangent line, we're looking for where is the slope undefined. So if we're looking for where the slope is undefined, this is the slope right here. So to find where it's undefined, that would be where the denominator equals 0. So I'm going to take 3y squared minus x, set it equal to 0. And then I'm going to add x to both sides, so I'm going to end up getting 3y squared is equal to x. So whenever x is equal to 3y squared, that would be where the tangent line will be vertical, when it does say to actually find those points. So what I am going to do to get this, I actually have this equation that has 2 unknowns, and I have this equation up here that has 2 unknowns, so I can put those together. I'm actually going to substitute this in where I see an x. So I'm going to have y cubed minus my x, which is 3y squared, y equals 2. And then continuing to combine this, I'll get y cubed minus 3y cubed is equal to 2. So I'll get negative 2y cubed is equal to 2. So that will give me y cubed equals negative 1, which makes y equal negative 1. So that's my y value. Now if I go back into my x value, I'll just plug it in up here. And when I do that, I'll get 3 times negative 1 squared is equal to x. So x will equal 3. So the point, the coordinates would be 3, negative 1. All right, that was equal to 3 points. If you took 3y squared minus x and set it equal to 0, you would get a point. If you found the equation in one variable, so this right here, you would get another point. And then if you found the coordinates, you would get your third point. Oh, that was worth 1. All right, part C, evaluate d squared y dx squared at the point on the curve where x equals negative 1 and y equals 1. All right, so this means, once again, the second derivative, and they already gave me the first derivative, so that was nice. So from here, we are going to use the quotient rule. So this will be my f, and this will be my g. F prime, the derivative of y, will be 1 dy dx. We're using implicit here. My f prime will be 6y dy dx minus 1. All right, so now I'm going to have d squared y dx squared is equal to f prime times g. So dy dx times g minus f times g prime all over g squared. Okay, now from here we can just plug in what we want, everything. Dy dx, we already found out in part B was equal to 1/4. And then 3 times 1 squared minus negative 1 minus the y value is 1. 6 times 1 times dy dx again was 1/4 minus 1 all over 3 times 1 squared minus negative 1 squared. All right, so I'm going to have 3 times 1 squared plus 1 is going to be 4. So 4 times 1/4 will be 1 minus 6 times 1/4 will be 3 halves minus 1. 3 halves minus 1 will be 1/2, so it's going to be minus 1/2 over, let's see, this will be 4 squared, that will be 16. So I'm going to have 1 minus 1/2 is 1/2 over 16. That will be the same thing as 1/2 times 1/16, which will equal 1 over 32. So if you used implicit differentiation, which we did here, you used the quotient rule, and then you remembered to do dy dx when you took the derivative of the y, that was worth 2 points. Okay. If you substituted dy dx in, so if you plugged in 1/4 for your dy dx, that was worth another point. And then if you actually found the answer of 1 over 32, that was your last point.